logs. Okay. So here is your division rule. If you see division, it becomes subtraction. Same thing as exponents. And our last one. There's also, just like there was with exponents, there's a power property. So again, not a crazy log, something we could very easily solve. I think we already did this one actually. So we could say 3 to what power is 27? And that would tell us power 3. But could we write this as a power? So could we have log base 3 of, and what's a way that I could express 27 as a power? I believe it's going to be 3 to the third power, right? And if you think about this, another way of saying this is just log base 3 of 3 times 3 times 3, 3 times 3 times 3, right? So the power tells us how many multiples or how many copies of the number we have, and based off this earlier rule, the multiplication rule, it tells us when we have multiplication inside of a log, which we do right here, we can turn that into addition of separate logs. So this one would be log base 3 of 3 plus log base 3 of 3 plus log base 3 of 3. So what I want you to notice is there's actually 1, 2, 3, 3 copies of this. So where did that 3 come from? This exponent right here. So this will tell you the number of copies of the log. So let's see. So from the beginning, we could have written this as 3 log base 3 of 3. So notice that I moved that exponent here. It might help if I wrote it in red. So that's the red 3. This is the green 3. Okay, so again, pretty much what I did is I threw that in the front. Let's look at another example. Oh, sorry. And if you worked with this one, you would see that it would be 3 times. Another way to say log base 3 of 3 is just 1, which gives you 3, which is the answer that you had right here. Let's look at one more. So we have log base 2 of 16. Again, a log that you could very easily do in your head. Just treat it as 2 to what power is 16. You'll get 4. But could I express this as a power? So I could write this as log base 2 of, let's say, I don't know, 2 to the 4th power. 2 to the 4th power. And if I expand this, this is log base 2 of 2 times 2 times 2 times 2. And according to our multiplication rule, this could be written as log base 2 of 2 plus log base 2 of 2 plus log base 2 of 2 plus log base 2 of 2. So again, you see that the exponent, the 4, tells us how many copies of that log we have. So that's 1, 2, 3, 4. So we had 4 copies of that. So pretty much it's the same as taking this power and just throwing it in the front. Because I can rewrite all of this as 4 copies of log base 2 of 2. See how the 4 kind of jumps to the front? So let me go ahead and do this power rule. It's not exactly the same. I think the other two are a little bit more synonymous with the exponent, but let's say we had log of a to the b power. That's pretty much the same as taking this exponent and bringing it to the front. So we can say that this would be equal to b times log of a. So when an exponent is expressed within a log, it is the same as the coefficient, right? Coefficient is the number in front of that log. Or you can think of it as the number of copies of that log. Okay, so again, just quick recap. These are the three main log rules. We have the multiplication rule, which very similar, says if you have multiplication inside, that turns to addition. We have the division rule, which says if you have division inside, that turns to subtraction, same as the exponent rule. And then we have the power rule, which says if you have a power inside, it's pretty much the same as moving it to the front. Okay, so that's the summary of the properties, and I'll be in the next video using these properties to make logs more simple and more complicated. Alrighty, good morning everybody, Mr. Motorhorn here, and in our previous video, I talked about where these log rules or properties come from, and I wanted to show you with a couple of these delta math problems how we could apply these rules to either expand or condense logarithms. This one specifically I'll talk about expanding. In another one I'll talk about condensing, but they're pretty much similar processes, just going backwards. So I'm going to focus on this first problem. Just before we go, just recall the relationship here that if you see multiplication inside of a logarithm, that becomes addition of two separate logs. If you see division inside of a logarithm, that becomes subtraction of two different logs. And if you see a power raised to another power, that power actually ends up moving to the front of the log. It tells you the number of copies of that log that you have. So I'm going to go ahead and start with this one. So our directions say to expand the logarithm, and this is level 1. There's also level 2, which the only difference is it makes use of fraction powers, which we'll go over in a second. So expand the logarithm fully using the properties of logs. Express the final answer in terms of log x and log y. Okay, so here's our problem. We can write it as log of x squared over y cubed. And so we want to expand this. So this is written as one log, and we want to try to write it as more logs if possible. Okay, so first thing is I would go to my log rules, and I would ask myself, what structure does this look like? Does this look like something multiplication rule? Does it look like something division rule? Does it look like something power rule? And I think you might be able to tell that it definitely looks like this one right here, the division rule. So I'm going to go ahead and apply that rule, and what it says is if I see division inside of a logarithm, that becomes subtraction of two separate logs. So let me go here, and then this is going to become log of x squared minus, so remember division becomes subtraction, minus log of y cubed. Okay, so that was the first property. And then now I'm going to look and see if I see other properties. So I don't see multiplication anymore. I don't see division anymore, but I do see now a power raised to another power. Or sorry, not power raised to another power. I see a base raised to a power. So that'll be right here with this 2 and this 3. And so what the property says is you are able to take that exponent and toss it in front of the log. So I'm going to take my 2, throw it here. I'm going to take my 3, throw it here. And so the final answer to this expansion of the log would be 2 log of x minus 3 log of y. Ta-da! And that's pretty much it. I mean, you're just looking for these various properties and applying them as needed. Okay, next one. So, let's see. So this one we have log of x over log of y to the 5th. Again, we're expanding. And again, if I asked you to look at these properties, hopefully you would see that you have another application of the division rule. So just look for these structures when you're doing these problems. So this is another division. Oops, division. And so I can write it as, if I have log of x over y to the 5th, I can write that as log of x minus log of y to the 5th. So very similar to the last one. And then if you look at this one, this first log looks pretty done. We can't really apply any other rules. There's no multiplication, there's no division, and there's no exponent to move. But if we look at this second log, there is one more property we can apply, and that is the power rule. So what the power rule says is we can take that exponent, throw it in the front of the log. So my final answer to this would be log of x minus 5 log y. Okay. And then here's one more example. This one doesn't use the division rule. This one actually uses the multiplication rule. You can tell because multiplication. You can tell because the x to the 4th and the y cubed are being multiplied together. So I'm going to go ahead and write that out. Let's see. Log of x to the 4th y cubed. It might help if you remind yourself that there's like a multiplication dot. They won't really show it in the problem, but you know that that means multiplication. And so according to our rule, it says if we have multiplication inside the log, we can turn that into addition of 2 separate logs. So I can write this as log of x to the 4th. Notice this time it is addition plus log of y to the 3rd. And then we look again for any additional properties. I see a power both here and here. So I'm going to bring that to the front. That's the power rule. So I can write this as 4 log of x plus 3 log of y.